All right, right now I'm going to have you write down these properties here because that's what we're going to use to find these compositions. So just take a second to pause this video and write down these properties. We'll talk about why they work out the way that they do. But again, just write down what I have underlined here as we're going to use these to solve and evaluate some compositions today. So go ahead and pause the video. And once you're done, we'll go through some examples. All right, so let's go through these examples. And with the properties right in front of us, it's a pretty quick thing to evaluate. Again, we'll talk about why they work out the way that they do, which ends up being a little more complex. But if we've got these properties in front of us, I first identify, okay, I'm taking the inverse cosine of a value. I want to make sure that that falls within that domain. Okay, and we can take inverse cosine of values that fall in between -1 and 1. Okay, and so since 0.6 is in the domain of -1 to 1, that tells us that the property works out, and thus the value here is just simply 0.6. Okay, there's nothing more that we need to do. It's just using that property. And again, we'll come back and explain that here in a second. Okay, so basically we're taking the inverse cosine of some ratio to come up with an angle. Based on what the angle is, we take cosine of that angle, ends up being 0.6. All right, now part B, this time we're starting with sine of 3 pi over 2. And this one we actually, the answer is not just 3 pi over 2 because of values and restrictions we get within the domain. Okay, so this one's a little bit trickier, and this is why we have to think about, okay, what are we exactly solving for? And I always start with the inside function. What does that represent? Well, when I take sine of 3 pi over 2, I know that corresponds to some value on the unit circle. Okay, so really, if we think about sine of 3 pi over 2, well, that's the y coordinate down at the negative y-axis, which is -1. So we're actually taking the inverse sine of -1. And so now this almost turns into a problem like what we did yesterday, to where I can set this equal to theta, and we're trying to figure out where does sine of theta equal -1. And we have to look within the domain restrictions of inverse sine. So inverse sine, the domain is -pi over 2 to +pi over 2. And so we're looking for a y value in between -pi over 2 and +pi over 2. And we're going to get that y value of -1, okay, or sine of theta to equal that -1 at the angle of -pi over 2. So the answer to this one, even though we followed this property, ends up being -pi over 2 because of that domain restriction. So yes, 3 pi over 2, that equals x. That would be the coterminal angle here. But we can only get the values between -pi over 2 and +pi over 2 because of how that inverse sine works out. So our answer here is -pi over 2. Okay, for what part B equals. All right, and then part C, yeah, Blythe, go ahead. All right, in part C, okay, I'm starting with the inverse cosine, and I'm first checking what kind of values am I allowed to take here. Well, with inverse cosine, we're only able to take the inverse cosine of values between -1 and 1. Okay, so this is 1.5, and because 1.5 is not in the domain of -1 to 1, then this value is undefined, and it cannot be evaluated. So to kind of explain this, we're going to actually use right triangles, okay? And I want to start with, we're going to always figure out what is the inside function telling us. Well, the inverse cosine or cosine of -1, inverse cosine of 0.6, remember, typically we set that equal to theta. Okay, so this means that cosine of theta equals 0.6. So then I start thinking about, what do I know about cosine in terms of right triangles? I know that cosine is equal to the adjacent side over the hypotenuse side, which I can put 0.6 over 1 to make that a fraction. And now I have lengths for the adjacent and the hypotenuse side. Okay, so I'm going to go ahead and draw this triangle oriented in our usual XY grid. So positive 0.6 being the adjacent, and we'll put this in quadrant 1. So we have our angle theta here, which we don't even need to know theta. Okay, but cosine of theta, the adjacent side here is 0.6, and the hypotenuse is 1. And so all we did is basically break down what inverse cosine of 0.6 meant. Okay, it meant that at some angle, we get the adjacent side over the hypotenuse side to be 0.6 over 1. So now what we're really trying to find, okay, since inverse cosine -1 of 0.6, remember that this equals some angle. And we don't even need to know what that angle is. We're just calling that angle theta. So really all we're doing here is using that inverse cosine to say at some angle we develop this triangle, and now that some angle being theta, we just need to find cosine of theta. Cosine of theta here is once again the 0.6 over 1, which is just 0.6. Okay, so using that triangle, we get cosine of theta to just be 0.6. We never needed to know what the exact angle was. All right, so let's see how that works out with B, okay, using the same idea here. Now, B is a little bit different because now we're starting with sine of 3 pi over 2. And we want to think about, okay, what does that mean? Well, sine of 3 pi over 2 means that at some angle, sine of 3 pi over 2, we have an opposite over hypotenuse side. And I recognize this value as being something on my unit circle, right? At 3 pi over 2, that's down here, which is 0, 1. And what we're going to do is create basically an impossible triangle down here at 0, 1. Okay, so I'm just going to extend this angle out, even though it is going to be, I drew that wrong, 3 pi over 2. And so we're going to make just like a fake triangle here. And every time we're using these triangles, the x-coordinate is the horizontal length of 0. The y-coordinate is the vertical length. And with us being on the unit circle, I get a hypotenuse of 1. And so sine of 3 pi over 2 here, and sorry, this was actually -1. We get the opposite side of this angle being -1 and the hypotenuse being 1. So -1 over 1. And so that's where we got the, so since we know sine of 3 pi over 2 is -1, that's what brings us back to that inverse sine of -1, okay, after evaluating this value. And then inverse sine of -1, that's exactly what we did yesterday, right? In fact, we did that exact problem yesterday, and basically to evaluate that is the work that we had already done, okay, where we think about, okay, within the range, or if I set it equal to theta, we're figuring out sine of theta, where does it equal -1? So at what angle does sine equal -1? Okay, well that's at, and within the range, or within negative pi over 2 to positive pi over 2, because of how we restrict the domain with the inverse trig function. Okay, and so that's why we have to conclude that it ends up being negative pi over 2. All right, so with that one, we basically end up doing the same work that we did the first time. Just wanted to kind of show how this circle or the triangle can play into the way we solve this. All right, and then let's do this last one with C. And we're going to see here with C, with triangles, why it works out to be undefined. Okay, so with C, I'm starting with the inverse cosine of 1.5. Well, once again, if I set this equal to theta, and I get cosine of theta equals 1.5, I'm trying to find at what angle, actually I don't even need that. Let's again use the fact that cosine of theta is the adjacent side over the hypotenuse side. So I'm going to put this over 1. And so when I go to make my triangle here, well, if this is theta and the adjacent side is 1.5 and the hypotenuse is 1, does that work? What's the problem here? If you were to look up in the dictionary or some math like terminology and you looked up hypotenuse, what would it tell you? Is this the longest side, the hypotenuse right now? No, right? So that's how we know right off the bat this is a problem, okay? Because the hypotenuse needs to be the longest side, but it's not. The adjacent side is the longest side based on the information that we had here, okay? So this cannot happen, okay? And since it can't happen, that's just a way to kind of explain why this value ends up being undefined using triangles, okay? So when you're working through these, yes, you can just use the properties, but you're going to see here in a second, we're going to use some that don't fall into these properties, and drawing the triangles is going to be a way that we can figure these out, okay? These are a little tricky, and they're, yes, we can evaluate them, but understanding them takes some time. Okay, questions here before we work through just 2 more examples. So here's where the triangle work is really important, because here in example 7, we don't have a property that we wrote down in our notes that has cosine and then inverse tangent. So we really have to think about, okay, what information can we gather from what's provided? Okay, so I'm going to start with the inside function and break down what this is telling me by making a triangle. Okay, but before I even get to that triangle, I'm going to take the inverse tangent of 5/12 and set it equal to theta, meaning tangent of that theta equals 5/12. So at some angle theta, we're going to get the opposite side over the adjacent side to be 5 and 12. So I'm going to draw that triangle now. So we get some angle theta to where the opposite side is 5, the adjacent side is 12. And we're trying to find cosine. So from this triangle, we now need to find cosine of that same angle theta. And we know that cosine of theta is the adjacent side over the hypotenuse side. So I need to find the hypotenuse here, which I can find by doing a squared plus b squared equals c squared. It's 25 plus 144 equals c squared, making c equal 13. Okay, square root of 169 is 13. And now that I know the hypotenuse, I can find the value of cosine by taking the adjacent side of 12 over the hypotenuse of 13. Okay, so this whole composite equals 12 over 13. Okay, which is what we're trying to evaluate. All right, I'm going to have you all do one more here in just a second, and then that'll be it for today, and you'll be ready to finish that Math Excel assignment. So first, break down what inverse sine of 1/3 represents. Use a triangle, and then using cotangent, see if you can find the value of this composite function. Okay, and this will be the last thing that we do. So again, I start with, we mainly focus on what's going on with this inside function, so the inverse sine of -1/3. So I start with that, and I set it equal to theta. So meaning I'm trying to find out where's sine of theta equal to -1/3. Okay, so at what angle? Now, that particular angle needs to be within -π/2 and +π/2, telling us that we're either in quadrant 1 or quadrant 4. Well, sine being the y-coordinate, and this being negative tells me that I need to be in quadrant 4. So I'm going to draw this triangle and use this value, okay, or the opposite of hypotenuse, to be in quadrant 4. With sine being the opposite side, that's what I'm going to make negative. That's what makes sine negative, with that y value being negative, and the hypotenuse then being just +3. Okay, with these triangles, the hypotenuse is always positive. Okay, and so then using the Pythagorean theorem, I'm finding the other leg, specifically the horizontal leg. That's why I use the variable of x. And so the vertical leg squared plus the horizontal leg squared equals the hypotenuse squared. And you end up getting x to be root 8. And that reduces down to 2 root 2 after factoring out a root 4. So now that I have my triangle, when I go to find just cosine of theta, I'm taking the adjacent side over the hypotenuse side, which ends up being 2 root 2 over 3. Yeah, Blythe. Ah, yeah. Good call. Let's try that again. Cotangent of theta is the opposite. Well, tangent is opposite over adjacent. So this is adjacent over opposite. So that ends up being 2 root 2 over negative 1, which is negative 2 root 2. Very different than what I came up with since we're finding cotangent, not cosine. Good call. All right. We'll skip that last problem. The last problem was more of like a challenge that we're not going to see on the Math Excel anyways. So that is it for today.